Hello everyone, another nice short sweet video today on lattice enthalpies and ions in solution. So last time, during our video on Born-Haber cycles, we talked briefly about lattice enthalpies. They make a few assumptions that we need to be aware of. First of all, they assume that the ions are completely spherical. They also assume ions are point particles and that ions have no an even charge distribution and no covalent nature. These assumptions lead us to a few errors in our calculations, like differences between theoretical and experimental delta H of lattice formation values. If the ionic compounds are slightly electronegative, this will lead to a more endothermic delta H value than the theoretical one predicts, as there are more charges to overcome, as this is the slightly small covalent force. Moving on to ions in solution, this is our new topic. It's very hard to measure the delta H of solution values experimentally due to the heat transfer of surroundings and the fact that ions don't instantaneously dissolve. Instead, we have to find the values another way using a Hess cycle. Fortunately, the Hess cycle in this example is a lot more simple than the Born-Haber cycles we looked at last video. We start off with an example of aluminium oxide and we split it in two directions. We use our delta H of lattice dissociation to turn it into 2 aluminium ions and 3 oxygen ions, and we use our delta H of solution to do the same except in aqueous solution rather than gas. There is an error on the video there. That should be an AQ rather than a G by the oxygen. On the solution side, we then use our delta H of hydrogenation to convert our gaseous ions into aqueous ions, and so that will give us 2 times the delta H of hydrogenation of aluminium because we have 2 aluminium ions, and 3 times the delta H of hydrogenation of oxygen because we have 3 oxygen ions. And then we can simply combine these values into a quick algebraic equation which gives us the delta H of solution of aluminium oxide. As always, leave any questions you have in the comments below or ask them now in class. Don't forget to like and subscribe, and I will see you in a few days for our next video. Thank you.